Hi everybody, welcome back. So in today's video, we are going to talk about the ACID standards and what these things are. So ACID stands for Atomicity, Consistency, Isolation, and Durability. As you can see here, this is the graph I'm using. I made this using this platform. So ACID stands for Atomicity, Consistency, Isolation, and Durability. And these are the standards set for databases. Okay, so it is there to ensure that your transaction should be reliable and it shouldn't violate any rules that you have made for your database. Okay, so that's why it is used. And today, to understand this entire concept, we will take in help of banking system, like how that works. And it's not like how that works, but sort of an idea you will get from there, like how these ACID standards works. Okay, so let's start with the atomicity. We are going to define the atomicity here. So atomicity is an important concept in a database system. It is a property used to ensure that the transaction performs smoothly and reliably. Okay, so it basically defines let's say you are doing some sort of a transaction, and in that, you have a multiple database queries that will be executed. So it says, in case if any of that goes failed, okay, if any of that queries goes failed, then you have to roll back all of the changes that you have made so far. This is the diagram I made for Atomicity to explain you. So for example, let's assume the user A wants to transfer money in user B account. Okay. So in that case, there will be two things that will happen. The first thing will happen is the money will get debited from user's A account, and then it will be credited to user's B account. Okay. So in this case, if any of that goes fail, okay, let's say debit from A is successful or somewhat successful, but when it comes to doing that second operation, crediting into B account, then due to some technical errors, it didn't happen. Okay, and it failed because of something. Okay, in that case, what it says, like, you have to roll back all the changes, like even this one and even this one. So that's what atomicity means. Like, so if any of that queries goes wrong, not queries, but any of that operation goes wrong, then you have to roll back all the changes. So that's what atomicity means. And here you can read this is to ensure like the transactions perform smoothly and reliably. Atomicity ensures that either all the operations of an atomic transaction, such as insert, delete, or update, complete successfully, or none of them do. Okay, so this is a very important thing. And after that, there is another concept which is called consistency. Like, it's one of the ACID standards. Consistency, basically what it means, let me show you also this by an example. So the consistency means after performing the transaction, the data should be database should be from one valid state to another valid state. Okay, for example, let's see, this is the let me explain you this by example. So consistency is kind of sort of a rules that you set for your database, and you suppose that, like, you assume that none of the operations should violate those rules. Okay, for example, if a user A has 500 US dollar in his bank account, and if he'll try to transfer that $600, then it should not be allowed. Why? Because we have a rule that money cannot be negative in a bank account. Okay, so that's why if anything like that happens, then you have to make sure that operation should automatically get failed. That operation should be failed. Okay, that's what I mean. So that's what consistency means. Okay, and also, like, there is another example consistency you can take. For example, let's say user A has X amount in his bank account. Okay, user A has a X amount in his bank account, and user B has a Y amount in his bank account. And if now user A has sent like a $200 from his bank account to user B account, then user B's account should be increased by only 200, not more than that. So regardless of how much money has been transferred, the total amount of both accounts should be the same. Okay, there should not be any excess of money, or there not should be any a decrease of money. You are just transferring from one bank account to another bank account. So that's what consistency means. This is like a set of defined rules that you decide for your database, and it should it should not violate them. Okay. And after that, there is a thing called isolation. You can go through this graph as well. I'll mention that in the description if you want to. So let's talk about the isolation thing. Okay, so isolation here you can see like it's a concept that applies to database. It means that when multiple people are accessing and updating the same database, the changes made by one user won't affect the changes made by another user. Okay, so let's try to understand this by example as well. So let's say user A has $300 in his bank account. Okay, and now what happens? Like what is happening? User A and user C, both of them are trying to withdraw $200 from user A's bank account. So in this case, if both of the transaction is happening at the same time, you have to make sure that both of these transactions should be isolated. Okay, like you have to queue them or whatever you can do, but these should not interfere with each other. So in this case, if like user A withdraws, like 300, like 200 from 300, and now even user C will withdraw the 200 from a 300, then it will be an overdraft, which shouldn't be the case. Okay, so that's what isolation means. Like you have to keep all the transactions isolated. They should not interfere with each other. So in this case, like you have to some sort of queue them, like like you have to perform these operations independently, like in a queue or whatever you can imagine. But yeah, that's what isolation means. And the last but not the least is durability. Durability is like once changes are made, it's a permanent. Let's try to understand this by like what it says. Durability means that something can last for a long time without breaking, wearing out, or needing to be replaced. It's a very simple. Okay, so as its name sounds, the term ACID is used to describe the set of rules that make sure a piece of technology or software is able to remain durable over time. Although I have not made any diagram for this, but it's like pretty much simple. So let's say user A has sent X amount in user B's account, and okay, and after and also like transaction has been confirmed, like it's successfully confirmed. So even after that, just a moment after that, even if the like entire database system crashes or like entire system crashes, it doesn't matter. That transaction should be permanent. You have to make sure that anything happens, it doesn't matter, like that transaction should be permanent. Okay, so even next time when that system starts running, then user B's account should reflect that 200 rupees that was created by user C account. Okay, so that's what ACID standards are. I know it was like very fast, and it was just a quick explanation video. I thought like I should explain this because even I am trying to understand this, and it's really useful. So yeah, let me know what is your thoughts, and if you really like this video, then don't forget to hit the bell icon and subscribe this channel. I'll see you in the next video. For then, goodbye.